Okay, so with regard to this integer division, that's this one here, uh, what happens is if you do 6 divided by 5, usually it would be 1.2, but what happens is the remainder is discarded, or the fractional part is discarded, and all you get is 1. Okay? All right, now let's go on. Okay, let's talk about math statements. So in our previous example, we saw that we saw a math statement. So C equals A plus B. Remember, these were numbers. Question: what does the statement x equals x plus 1 do? So if you think of this as a math statement, it's impossible. It's nonsense, right? You can't have x equals x plus 1. If you put in 5, that would say 5 equals 6, right? But we do write this. So what does this mean? So you have to remember that this equal sign is the assignment operator. So what it does is, well, let's look at it here. So what does this mean? It says first get the value of x stored, get the value stored in the variable x. So remember, we have something stored in memory, some value stored there. So first we get that, and then add 1 to that, and then assign that new value. So suppose 5 was stored in the memory, so then it would be 5 plus 1, and then store that in memory now. In other words, store x plus 1, store 5 plus 1 in memory. In other words, store 6 in memory. So you can see it's just exchanging what was in the memory before for some new value, which is incremented. We say incremented by 1. Okay? So let's look at an example here. Suppose dim x as integer equals 10. Well, we said that we can do this. We said this is called initialization. And so we do it. And so that means that x now is equal to the value 10, or the value 10 is stored in the memory position where x is labeled. Okay? So x has the value 10. Now what do? We read what's in that memory space, which is 10, add 1 to it, and then store that, which is 11, back into that same memory space. Okay, that's the idea here. So during runtime, that means when the program is running, the right side is first evaluated to yield 11. That is, this side is given 11. Then this result, 11, is passed to the left side. So the result then is x is equal to 11. Now, sometimes, I don't know why, but people got tired of writing something like this, or for example, writing like something like this over and over again, and they wanted a shorthand, and the shorthand for this is this. Now it's not such a lot. You don't save that much here, so it seems a little bit unnecessary to have this shorthand. But you need to learn this because people will use it all the time, even if you didn't want to use it. So how much savings in writing do we get out of this? So this and this are supposed to mean the same thing. So what do I do here? I have to write n. I wrote n there. I have to write equals. I did write equals here. I wrote n, so I didn't have to write n twice. And then I wrote plus. I had to write plus there. I had to write it. So the only thing I saved in creating this new notation is not having to write n one extra time. That doesn't seem like it's really worth it. But anyway, that's what they have. Okay, so you need to get used to this, at least to be able to know what it means. So what does it mean? It means this. In other words, it means take n and add 8 to it to create a new n. Okay, so we say we're incrementing n by 8. Same thing here, we're incrementing n by 8. Okay, or you could do it with, if I wrote n plus equals 1, that would mean I'm incrementing n by 1. Okay, and then you can do it not just for plus. In other words, if you had plus here, you would use this one. But if you had minus here, you could use this one. And if you had times here, you could use this one. And if you had divided here, you could use this one. Okay? So they say more generally, a math statement takes the form like this, where the left side is a variable. This will be a variable like x equals something on the right, while the right side is a mathematical expression, so it could be a number, but it could also be an expression. So at runtime, that means when the program runs, the right side is evaluated, so this side is evaluated, and then passed to or assigned to the left side. For instance, as a result of the statement z equals 2 times 3 at runtime, the first side is evaluated yielding 6, then the result is passed to z, setting z equal to 6. What about a compound statement that is with several math operations? So suppose we have this. So if you think about this, this could be ambiguous. So what do I mean? So if you do 2 plus 1 first, you get 3, and then 3 times that is 9. But if you do this first, the multiplication first, you get 6, and then plus 1 is 7. So we have to, so we don't want ambiguity there. We want to have a single meaning. So we have to, so what we can do is we can decide on an order in which to do this. So we just make a rule. So we say that this multiplication is always done before addition, unless you put parentheses around this, in which case the addition would be done first. He says which one is correct. So in Visual Basic, the order of evaluation of math operators is determined by precedence. In other words, we just decide, we just make a rule that we're going to do certain operations first, and that's called operator precedence. For arithmetic, the order of evaluation is, this is done first, so this is exponentiation. I think I explained this before. So this means if I wrote a 3 here and a 2 here, that means 3 squared. If I wrote a 5 here and an 8 here, that means 5 to the 8th. So this is exponentiation. So that's done first, always. This is done next. Now this is not addition and subtraction. This is, if you want to say -6, you'd write this. It doesn't mean minus 6. It doesn't mean subtract 6. It means -6. So that's done next. Okay, if you have that. Then multiplication and floating point division are done next. So these and these are done next. And then integer division follows that. And then mod follows that. And then addition and subtraction are last. So in this case, remember, we have this comes before this. So we do 3 times 2 first, and then we add 1. Okay, what happens when the compiler encounters several successive operations with equal precedence? Let's see, is there an example of that? So 6 times 2 divided by 4 times 3. So we said that multiplication and division have equal precedence. So which do I do first here? Do I do this? Do I do this? Do I do this? So it goes in order from left to right. So in that case, it's going to be, I don't know, I guess you can't really see this, but maybe you can see it. This says 6 times 2 divided by 4 times 3. So what do we do first? First we do 6 times 2. So that gives us, this says 12, by the way. You can't read that. And then divided by 4 times 3. So it'll be 12 divided by 4 times 3. So the 12 divided by 4 happens first. So we get 3, this says 3, times 3. Okay, so the answer is 9. Okay, on the other hand, if you want to override the precedence, you can use parentheses. Right, so then we do what's in the parentheses first. Parentheses inside of parentheses. I think we know how to do that, so we won't go through that. Okay, I'll stop here and make a new video.